Hey everyone, welcome back to another video. In this video series, I will be introducing some interesting and novel research papers for you guys so that you can keep up with the latest updates in research. Today, we are going to glance through 4 recent research papers that I find to be really interesting and important. I will leave the link to their PDFs in the description below if you are interested in reading through them. So let's get started. The first paper I'll be introducing is called BuboGPT. So I'll be providing a brief summary of the key details from this paper. So essentially, this paper is focused on developing a large language model that is specialized for tabular data. And this is really important, right? Because many businesses work with tabular data all the time, data analysis with tabular data, right? But now we have large language models that are also capable of working with tabular data. And this model is pretty unique because it incorporates a novel cascaded table encoder to generate global vector representations of input tables. And this allows a comprehensive understanding of tables. And this model is capable of working with tables in many shapes and forms. For example, it's able to perform data manipulation, like inserting, deleting, updating table rows or columns, right? And it's able to aggregate, sort, filter, pretty much similar to Excel, right? Except that the large language model is able to interpret the user query and perform all these actions for the user. So you don't have to do all those mundane tasks on a boring Excel sheet anymore. You can just automate the whole process with a large language model that you can just query with natural language, right? And this model is also capable of outputting visualizations, and that means plotting different statistical graphs and plots and charts. So that's pretty important for data scientists and data analysts, right? And this model follows what is called the chain of command approach, which trains the model to decompose complex table modifications into executable command sequences. So what do I mean by that? So I'll be providing an example of what this approach is. So suppose a user provides the query, show sales by product category over time. And they input this to the BuboGPT model as natural language, right? And with chain of command, the model will be able to break this query down into these steps, right? First, it will group the table by columns, product category, and date, right? So it's able to automatically do this without the user having to do these tasks themselves. And then step 2, it will try to aggregate the sales column by summing values within each group. And right, again, the user doesn't have to do anything on their side. It's the large language model taking care of all these steps. And then it's able to plot the aggregated sales time series for each product category. And then finally generate a text summary describing the key trends over time per category. So this paper is very useful for businesses and data analysts, data scientists, right? If they want to analyze some business data, this will be very easy to automate, right? For example, you are an owner of a mom and pop shop. You no longer require a data analyst to analyze how your sales are doing or which product you should sell more, right? You can do this all on your own just by asking this model. I see this as the future of how businesses are going to operate, right? They're no longer going to be needing all these analysts when they can just simply query large language models on their own. So maybe your local mom and pop shop will be using these sort of models in their local stores for analyzing sales and different things, right? Okay, so the next paper is really important. It's called Retentive Networks, also called RetNet. So what is this paper about? The paper essentially showed that RetNet is potentially a new foundation model architecture for large language models. And basically, it performs better than Transformer when it comes to being a foundation model for large language models, right? So you can see from the graph here that it has better perplexity and it's much faster, right? Look at the latency, right? And also it takes up less memory in terms of GPU memory, right? vCPU. So overall, it just performs better than the Transformer in every way. So how does it do this? Well, for training speed, its parallel and chunkwise recurrent representations enable faster parallel training compared to Transformer. So it's more efficient. And for inference, it allows for constant O of 1 inference complexity rather than O of n, right? So we're cutting down from a linear time complexity down to a constant time complexity. And that is huge, right? This scales much better. Okay, and it's also very much capable of handling long sequence modeling compared to the Transformer. So this is another benefit of using this model as a foundation model, right? And furthermore, scaling, right? It outperforms the Transformer once the model size goes beyond 2 billion parameters. And most open source models nowadays are far more than 2 billion, right? We're seeing 7 billion, even 40 billion, 70 billion parameters, right? So 2 billion is really not a lot. So I just see the future of open source large language models being built upon this retentive networks model. This paper is really important. I think it's going to dethrone Transformer. Of course, the Transformer is still going to be used, but in future research, more and more people and researchers are going to adopt this architecture. Okay, so we talked about performance already from this graph. It has lower perplexity, which is good, right? Okay, and the next paper is called AlpaGasus. I just find this paper to be really interesting because it essentially shows that data quality is more important than data quantity. We have all heard the cliche phrase, quality over quantity, right? And this paper basically demonstrated that. So what it did is that it first used ChatGPT to automatically score the quality of each instruction, which is like input and response in the training data. And this basically filtered out the lower quality data. So it cut down from 52K samples to 9K high quality samples for training. And at the end, it actually ended up outperforming Alpaca by only training on 9K data compared to 52K data. So it's more efficient as well. And keep in mind that since it's using ChatGPT, this whole process of cleaning the data is completely automated, right? So, we see less data, faster training, stronger performance, right? So, maybe in the future of training large language models, we'll just see more automation, maybe synthetic data, right? I think ChatGPT is very capable of generating very high quality synthetic data because, ChatGPT is very capable of creativity when it comes to conversations and in this case, instruction tuning, right? Okay. And lastly, we have this paper called BuboGPT, I believe it's pronounced. And basically, it enables visual grounding in multi-modal large language models, right? So, recently we have seen a lot of papers on large vision language models. And this paper basically builds upon that. It demonstrates improvements over previous large vision language models like Mini GPT-4, which was pretty big, and Java. I don't know how it's pronounced. And yeah, it's able to interact with audio as well, not just visuals and text like some of the other large vision language models. And it incorporates something called visual grounding, which is basically locating objects of interest, right? Detecting these objects of interest. And I believe this is actually open set detection. So it's able to detect the object of interest without being trained on these objects specifically. So it's sort of like the grounding dino paper. I'm not sure if you guys have seen that paper. Basically, based on user query, it's able to detect the objects of interest. That paper is a few months old now, so yeah. Anyways, so from this image, we can see that it's able to take in voice input and also text input, right? And then it will generate a response and then detect the objects of interest: boy, bicycle, dog, dirt road. I find it really interesting that it finds these objects to be more important than the other objects that are named, right? So that's pretty interesting. And this is like a larger diagram to demonstrate what this model is capable of, and also its model architecture, sort of. So it takes voice input, image input, and we kind of see this fusion layer here, right? And then we input it into a large language model. We perform visual grounding. There's also this paper called RetGPT, which performed a very similar architecture, actually. To show you guys what I was talking about, this was a paper from May called RetGPT. And I believe the approaches are really similar. For example, this paper introduced something called what is it called? Reasoning-based object detection, right? And it's sort of similar with this paper here. It also uses a large language model. It has a linear layer, and then it performs visual grounding to detect the objects, right? That GPT does something similar where it takes in input through a large language model and then detects the object of interest, right? We have a linear layer, right? Large language model, and it detects the object of interest, right? So very similar pattern we're seeing here. This is also sort of reasoning-based detection in some sort of way. So yeah, glad to see these new papers coming out. So I'll be linking the PDF to these papers down in the description below, and it should be pretty easy for you guys to find. All right, so this is the table GPT paper, right? So you guys can see that it's capable of returning a chart, right? A histogram. And it's able to plot stuff as well. This is in Chinese, right? Okay. And this is the retentive network paper we talked about. Has a lot of math in there. Not going to be reading through all of the math, but basically you just have to know that this paper performs better than the transformer. It's probably going to be the next transformer. And we have this AlpaGasus paper, which shows that data quality is more important than data quantity. It has a lot of graphs in here, which I really like. Typically, all the really good papers have really well-drawn graphs. That's something that I find to be interesting. These graphs are beautiful. And yeah, I guess that's it for this video. I can also link RetGPT and Grounding Dino in the description below as well if you guys are interested in reading more through those papers. And yeah, thank you guys for watching. I'll be making more videos on daily research papers in the future, specifically on papers that I find to be novel and interesting. So if that's the type of content that you guys would enjoy, please like and subscribe and turn on your notification bell, because I'll be doing an entire series on these novel research papers. All right, okay. Thank you guys for watching, and see you next time.